Good morning. This is a tour through our new home here in over in the Innsbruck area in a place called Oakland Hills. And we're trying to show you some of the things that we do in our homes at this stage that can give you some insight on the how and why of how things go together and why we do it. One of the things I'm going to focus on here is the I-joist, the silent floor system that we've placed. We stack those right over top of the studs so that the bearing load as it comes down through the house has got a way to transfer that load directly to a supporting member. And then that sits on top of the stud, and the upper floor joist sits right on top of the lower floor joist as well. So your transfer of load from the roof to the foundation is solid. And that doesn't seem to make a huge difference, but when you get to a 10 to 12 years in and you start seeing movement in the house, it really diminishes that dramatically. We use an Advantech flooring system. And Advantech is a superior subfloor. It is, it probably costs 25% more for a subfloor board as opposed to the normal 3/4 inch OSB, but it does not absorb water. It does not swell up. It stays flat and stiff. It is just a much superior, much quieter, much more durable floor system. And it's just one of those things that we have used for a number of years now as a result of experiences that we had in previous systems. One of the things that we've taken to doing is to, on our I-joists and our LVLs, this blue beam is called an LVL, is to glue and screw those together. And what we have found in time is that you get a superior, the two beams tend to move together, together as opposed to separately. And as well, they will not open up, which is one of the problems that you run into on a big cased opening like this, is that the two beams will move independent of each other, spread apart, and cause a crack in your sheetrock. And it's just a little extra step that we take as we are running our jobs with our labor. We come in and do this, and it just gives you a little tighter, a little more secure situation. Any double headers, any double windows, we've got a bigger header. Once again, we're stacking our joists with our studs down to our floor system. This two-story wall, the risk that you have with these two-story walls is that wind load will push them in, crack your sheetrock at the corners, and just create movement in that wall that'll give you little problems down the road. So you can see we've got these things absolutely stacked full of studs to provide wind bracing on those two locations. As well, in the corners, we're using what's known as a Tico, and we've got those in here at about every 5 feet, all the way up the wall, in an effort to, because it keeps the walls together. You don't get the hairline crack up through where those two systems come together. Because what'll happen, the exterior wall moves differently than the interior wall because of that, because of this band that you see, the humidity movement that you get in a house, the exterior wall will move less than the interior wall. So by tying those walls together, we just eliminate a little crack that you'll run into down the road. This is a little trick that we've done to allow expansion into the attic, we've run a conduit from the crawl space up through the wall and then leave it there in the attic for access at a later point so that you can run any kind of low voltage or communication wiring or electrical wiring for that matter up and down so that your expansion of the attic is easier. This is a small but pretty important item. I've got a stud here. If you buy the right grade of stud, all four corners of that stud are going to be in place. What you'll find when this is a West Coast timber material, it's shipped by rail here and protected from moisture and humidity, stored indoors basically, or under roof. And that may seem like an insignificant thing, but when you compare that and the moisture content of that stud to a Carolina-based material where you're really only looking at three corners to the stud, one of the corners is going to be bark all the way up and down. And the humidity content of that material is much higher. You've got a significant difference in the structural integrity of that wall down the road. As well, we use all 16-inch on-center framing as opposed to using 24-inch on-center on our non-weight-bearing materials or walls. Thanks. The way we put these trusses together with our interior walls, we have to be certain to attach our sheetrock to the wall, not to the truss. So as we're building these homes, we're careful to put our backer, which is that's the top of the board. It's the board that's nailed to the top of the wall. The sheetrock attaches to that, but not to the truss that is immediately outboard of that. And the point with this, and it's pretty difficult to catch all the locations, but the point with this is that as the trusses lift with normal humidity changes, it doesn't tear the sheetrock in the upstairs ceilings. Little thing, but it means a lot in terms of how that house stays together as time goes on. We bring our hose bib and primary water cutoff into the garage so that it's quick and easy to turn that off in the event of a problem down the road. As well, you don't have to crawl into the crawl space to drain your exterior hose bibs. In the electrical system, we use a 400 amp service in any of the homes that we do above about 3,000 square feet. And the idea there is to make sure you've got plenty of expansion and just the ability to service that panel and that system all the way down the road. A lot of the things that we do are intended for long-term durability as well as service for our clients.